Hello students. So today we are going to discuss what is tangent theorem. It is a continuity of the circles what we have discussed in the previous one. Okay. So in this tangent theorem we are going to prove that what it is, the two tangents, that is AP is equal to BP. Okay, that is what we are going to prove in this tangent theorem. You understand? So this concept will be using to solve the problems which is there in your textbook. Okay, here you can see that in circle. So first, given the circle, here O is the center, O is the center, and P is an exterior point. P is an exterior point, and then here you can see that OA is perpendicular to AB and OB is perpendicular to AB. Both it is perpendicular. Perpendicular means what it is? It is 90 degree. Okay, it will be 90 degree, and then the next one is here OA and OB are radius. OB are radius. So these are things which is given. Okay, the center O, and then P is an exterior point. Okay, here OA is perpendicular to what it is? AB, and OB is perpendicular to what it is? AP. Sorry, BP. It is BP. Fine. So OB is perpendicular to BP. Okay, the next construction. So what we have constructed means join OP. Okay, what we have constructed here, join OP. Join. This is what the construction we have done. Okay, we are joining here what it is, O and P. Did you hear any doubt? We understood? We understood the diagram. So according to the proof, the length of the tangents drawn from an external point to a circle are equal. So that means PA is equal to PB we have to do. Here given in a circle O, in a circle O is the center and P is an exterior point, and we are explaining about this. And here OA and OB are radius, and then construction join OP. Okay, now to prove that is AP is equal to AP. AP is equal to AP. Understand? Now proof. So for this proof, it's a very simple one. We'll be using what it is? Congruency. We'll be using what it is? Congruency. Understand? Here from the triangle, two triangles we consider, that is OAB and triangle OBB. So already we have seen in what it is, triangle similarity. How we have taken the order of triangle, in that only you have to compare the sides and angles. That way only you have to compare the sides and angles. So here you see that we have taken the triangle OAB and triangle OBB. So here you can see that triangle OAB. So OAP, here it is 90 degree. The other triangle is OBB. OBB. It is like this. You understand? Now in these two we have to check with the given. What it is given, according to that we have to check. Okay, here. So what are things you can take from here for our proof? 90 degree. That means angle A is equal to angle B. Angle A is equal to what it is? Angle B. What is the reason? 90 degree. So we got one. What it is? Angle. Yes or no? What is the angle it is? Right angle. What angle is that? Right angle. And then what is the other clue? OP is common. Very good. So OP is equal to OB. It is common side. Common side. So it is side. What is the next one?
most common angle. Common point.
Please see the diagram. One thing in the beginning I told you that.
Radius.
Very good. Clap. What is our which one is equal? Radius are equal. So here what we can say? Which two are equal now? OA is equal to OB. OA is equal to this or no? So it is radius. So when it is radius, this also what it will come? This also become side. Now compare this with this one with this. So angle A is equal to angle B. Both are in the second position. It is equal. Correct? Now OP, OP. You can see that OP and OP. It is in same position. Okay, and then OA is equal to OB. OA is equal to OB. That is also in the first we are having OA here, we are having OB here. Understood? So this is the way you have to compare the sides and angles. Okay, now we got a 90 degree and one common side and the radius. Three things we got. Which criterion we can use? SAS it is not possible. Now we see that OA is equal to OB. And then OP is equal to what it is? OB. Now you see that in between these two, whether we have any angles equal. So SAS we can't take. So we are having two sides, one angles. I don't keep on, you people are laughing, I know what's the problem. If anything is there, you please tell me. Not from now, from the beginning I watched it. It's not good. See that. Here, can you able to see that any angles in between this which is equal here? See, you should have side, angle, side. Then only we can use SAS. Here, whether we are having SAS format? No. And we don't have side, angle, we don't have. We are having only angle, side. In what it is, in congruency. We don't have what it is, side, angle. Clear? So what's the next one we can go? Very good. Who's that? Good. Why? Because that is what I mentioned 90 degree. RHS. Right angle, hypotenuse and one corresponding side. So here you see the right angle, hypotenuse are equal. Yes or no? OP is equal to OP is what? Hypotenuse. So 90 degree. Opposite is what it is. Hypotenuse is equal, and then one corresponding sides are equal. So therefore, by what it will come? By RHS congruency. By RHS congruency, what you can say that triangle OAP is congruent to triangle OBP. So therefore, if it is congruent, then we can say that by CPCT, the remaining angles and sides are equal. Remaining angles and sides are equal. Already these two sides we have compared. OA, OB, OP, OP. What is left over? AP is equal to what it is? BP. Therefore, by CPCT, AP is equal to BP. So hence, okay, this is what the tangent theorem. So please see that we understood what is given. Construction, you understood how we are taking the triangle OAP and triangle what will become? OBP. So we'll be comparing the angle 90 degree and then hypotenuse, okay, and then corresponding side. The radius is corresponding side. Therefore, by RHS. RHS is right angle hypotenuse side, corresponding side. That is what RHS. Simply by saying 90 degree, we can't say it is RHS. It should be what it is, right angle, the hypotenuse it should be equal, corresponding side it should be equal. Then only we can use RHS. Very clear? Okay.